I welcome you all to today's session, which is on circulatory system and cardiovascular disorders. This particular session is a part of Unit 1 in Course 1, wherein we are giving you a brief about all the various kinds of systems that are present in the body. So let us begin. Today we'll be covering the circulatory system. What is a circulatory system? What are the various components of the circulatory system? What is the structure and function of the heart? And what are the various kinds of circulatory circuits that are present in our system? Also, we will talk about the various components like cardiac cycle, blood pressure, types of blood vessels, and we will touch upon the disorders of cardiovascular system. So let us begin. What is the structure or what is the function of cardiovascular system? In our body, we have a pumping system that is known as heart, and this is the major component of our circulatory system. The major role or the function of the circulatory system is to transport nutrients, gases, waste materials within the body by means of blood. So, blood is the means or the vehicle by which various nutrients, gases, and waste materials are taken out from each and every cell, tissue, organ of our body, and oxygen and carbon dioxide gases are also exchanged. Now, there are two major components of our circulatory system, that is heart, and second are the blood vessels, which are arteries and veins. Blood, as we all know, is a fluid connective tissue which flows within our closed system, which comprises of vessels such as arteries and veins. And when these arteries and veins become very, very thin, very, very minuscule, when they have to reach to each and every cell in the body, then we call them capillaries. So we have in all heart as one of the component of the circulatory system, blood vessels like arteries and veins, and fine capillaries which are responsible for delivering nutrients and gases to even the minutest parts, that is each and every cell of the body. Now we know that the total quantity of blood in human body is around 4 to 6 liters. Let us now see what are the various functions of the heart, and first of all, what is the structure of the heart. Heart, as we all know, is a muscular organ which is present in the upper left part of the chest. It pumps blood through blood vessels, and in the heart there is a regular contracting system wherein the blood is pushed to the blood vessels and it can reach from the tip of your toe, that is, you may be 4 feet tall, you may be 6 feet tall, but the heart is able to deliver the blood even to the remotest part, which is the tip of your toe, to your even the head. So the entire conduction system or the circulatory system is run or driven by one pump in the body, which is heart, and it is the pumping action of the heart which is able to deliver the blood to all the parts in the body. Now, the heart itself is a muscular structure. It is definitely like a pump. We have in our houses, we have motors like water motors which can throw water from ground floor to the 5th floor, 10th floor, or whichever. So you can imagine how much power the motor has to have. Similarly, our heart in the body is like a pump which is pushing the blood to each and every cell and each and every part of organ of the body. This heart or the pump of the body consists of 3 layers. It is a muscular structure, it is muscular in nature, and it has 3 layers. The outer layer, which is the pericardium, is like a bag, and there is pericardial fluid in which the heart floats. Second layer of the heart is the middle layer or the myocardium, and it consists of contractile fibers. And third is the innermost layer, which is called the endocardium. So this is the structure of the heart, which is muscular in nature. Now, the internal structure, if I have to explain about the heart, human heart is made up of 4 chambers. Now these four chambers are, two are in the top, they are known as atria. You can see here in the diagram, this is structure of the heart, and this topmost two chambers are the atria. They are known as atria, singular, and lower are the two ventricles. So you can see I have divided and written here right atrium, right ventricle, and left atrium and left ventricle. So here, if we say our heart has four chambers and it takes blood from all parts of the body, which is through vena cava, that is superior vena cava and inferior vena cava, which takes blood from the entire parts of the body, that is the upper, the lower parts of the body, and it is deoxygenated in nature. That is, it is devoid of oxygen. So, blood from the entire part of the body comes to the right atrium, and from the right atrium through this valve, which is the tricuspid valve, it enters the right ventricle. Now, from the right ventricle, the blood then is pushed to the pulmonary artery. You can see here the arrow shows how the blood is pushed from the right ventricle to the pulmonary artery, and this is the only artery in the body which carries the deoxygenated blood. Where the blood is going from here is, it is going to the lungs. Why? Because the blood, as I said, is deoxygenated and the blood needs to be oxygenated again. So from here, pulmonary artery takes the blood to the lungs, wherein carbon dioxide is given up and oxygen is taken up by the blood. Now this oxygen rich blood then comes from the lungs via pulmonary veins, which are shown here, to the left atrium. Okay, so now the blood has taken up oxygen, it is oxygenated and it is ready to be delivered to the entire body. So pulmonary veins are the only veins which carry oxygenated blood to the heart, and the blood then reaches the left atrium. From this left atrium, the blood comes down to left ventricle again through a valve, which is bicuspid valve. Now what is the role of these valves? These valves are there to prevent the backflow. If the valves are not there and the heart contracts, it contracts with a lot of force. So when there is contraction happening, then it is possible that the blood again flows back. But this doesn't happen because there is a valve here. So from the left atrium, the blood comes to the left ventricle through this bicuspid valve, and it is again pushed to the aorta. From the ventricle, the oxygenated blood which has come is pushed to the aorta. This is the big aorta you can see here, and it is dividing into arteries, and these arteries carry the oxygenated blood to our entire body systems. So this was the structure as well as the function of the heart, that our heart is four chambered and the right part of the heart receives deoxygenated blood. It gives to the lungs through the pulmonary arteries, gets oxygenated, comes back to the heart by pulmonary veins, reaches the left atria, and then from left ventricles it is again pushed back to the aorta, so that the entire body now gets the oxygenated blood. And I have also told you about the role of the valves. Now in the lungs, the gas exchange has happened and the blood from the lungs now comes to the heart again through the pulmonary vein. Now I have to explain three circuits which I have already talked about. These three circuits which are present in the circulatory system are pulmonary, systemic and coronary circulation. When I explained you about the right part of the heart, that is when the deoxygenated blood comes and goes to the lungs through the pulmonary artery, it is one circuit. You can imagine that it is a shorter circuit wherein the deoxygenated blood goes to the lungs, gets oxygenated and comes back to the heart. So this short circuit is known as the pulmonary circuit in the heart. So there are basically three circuits. One is the pulmonary circuit and the second is the systemic circuit. In systemic circuit, the oxygenated blood which has come from the pulmonary circuit will come to the heart, and the heart will push it to the entire body, to the entire region of the body. Each and every organ, each and every cell will receive this oxygenated blood. So when this happens, you can see here in the diagram, our entire system, entire body gets enriched with the oxygenated blood. So here you can see in this figure I have explained how the red part is the oxygenated blood is carried to all parts of the body with through systemic circulation. But that is not all. When we are supplying the oxygenated blood, we are also giving out the deoxygenated blood, which comes out from various muscles, tissues, cells, and this deoxygenated blood by means of veins is carried back to the heart. So this is the second circuit, which is known as the systemic circuit. Third circuit of the heart, which the heart itself is a pump, so it needs oxygen, it needs nutrients to function on its own also. The muscle is beating, so how many times it beats? 30 to 40 beats per minute. Okay, so the heart itself needs oxygen, it needs nutrients, and this circuit, the third circuit, is the one which supplies blood to the heart muscle itself, and it is known as the coronary circulation. Now all this is happening through a very automated system, we can say, which is known as the autorhythmic cells. There is no factor which is driving that how the heart is going to beat, or except for our physical exercises, or except for our emotional status at times when we feel the heart rate goes up and down. Otherwise, the entire system of the heart, whether we are sleeping, whether we are working, it is an autorhythmic system. Well, you see that the normal human heart beats continuously due to its own inherent rhythmical electrical activity, and there is the source of stimulation, which we say, which is responsible for the beating of the heart, is a kind of a specialized cardiac muscle fibers, and these specialized fibers which are present in the heart, they are known as autorhythmic cells, and they are self-excitable. That means they can generate the pulses, they can generate the rhythm for beating of the heart. That is why they are known as self-excitable, and the cells which are specialized for that are known as autorhythmic cells. Now these cells, they generate the action potentials, and they are helping in the contraction of the heart, so that the rhythm of the heart, the heartbeat is maintained. You must have heard about pacemakers, which are put in some patients wherein the heartbeat is affected, the rhythm of the heart is affected. So the role of the pacemaker is naturally present in these cells, which are the autorhythmic cells, and they form, a conduction system. They have two functions basically, these cells, autorhythmic cells. First is that they act as a pacemaker, which helps in setting the rhythm for the entire heart, and secondly, they form the conduction system, which is, the route for propagating action potentials throughout the heart muscle, because the pulse is generated at a region which is known as the sinoatrial node. Okay, so when this pulse is generated, the entire heart has to act upon it. It is not that the pulse is generated and everything will happen on its own. No, when this electrical pulse is generated, the contraction of the heart starts, and the heart also starts functioning in a peculiar manner. That manner I will explain. What is a cardiac cycle, we will understand by means of this. But first, it is important to understand the role of autorhythmic cells, which generate this rhythm or the pulse, which is the first, you can say, self-excitable region in the heart which generates this rhythm. After that, the heart activity starts, and what happens is next is the cardiac cycle. Now, if I have to explain, as we saw in the diagram of the heart, that there were 4 chambers. 2 upper chambers are known as the atria, and the lower chambers are known as the ventricles. So when the sinoatrial node generates the impulse, the contraction of the heart begins. How? First, the 2 upper chambers, that is the atria, they will contract, and they will push blood from the upper chambers to the lower chambers. So when the upper chambers contract, then there is a slight gap after which the lower two ventricles will contract. Now, when these two contract together, first the two atria, then the two ventricles, then this particular contraction of the heart is known as a systole. Okay. And after that, after the contraction of the ventricles, the blood is pushed into the blood vessels. And once the blood is pushed into the blood vessels, the heart relaxes. And in this diagram, you can see I have explained how on the right hand side, the systole is happening, wherein all the four chambers are in a contracted position and the heart squeezes the blood into the blood vessel. So this is the role of the heart wherein a systole has happened, we say. And on the left side, you can see the heart again, after pushing the blood out, relaxes. The chambers are in a bigger state, they are in a relaxed state, they get enlarged to get more and more blood. So when there is a relaxed state of the heart wherein the blood gushes from outside back to the chambers, it is known as diastole. So this particular action of systole and diastole happening together, it forms one cardiac cycle. So when you are asked that what is a cardiac cycle or explain how cardiac cycle is happening, you have to say there is contraction of the heart in which the atria contract first, push the blood to the ventricles, then the ventricles contract and push the blood to the arteries, and after which the heart relaxes and it is ready to receive more blood, and then that is known as diastole. So this one cycle of systole, atrial systole, ventricular systole and diastole together forms one cardiac cycle. So this was about the cardiac cycle. Now next we have to also understand what is blood pressure. So these things are all related. You see, blood pressure is the pressure of the blood which is flowing in the blood vessels. So naturally when the heart is pumping the blood with a lot of force in the blood vessels, there will be some pressure of that flowing blood which will be exerted on the walls of the arteries, because arteries are the ones which will receive the blood from the heart, and that is why arteries have to withstand some pressure. So when that moving column of the blood, it exerts pressure on the blood vessels, then we say we have to measure blood pressure, and it is an important indicator. We all know when we visit a doctor in certain conditions, he measures our blood pressure because it is an important indicator whether our body, heart and other system is functioning properly or not. So in blood pressure also we have systolic and diastolic pressures. Now you know when systole is happening, then the heart is squeezing the blood out and this contraction is generating a pressure on the arteries in which there is a pressure, and this pressure normally ranges in the range of 110 to 145 millimeters of mercury. The blood pressure, it is expressed in millimeters of mercury, and when the heart relaxes, that is when diastole is happening, that is when the heart is getting filled by the blood and it is not contracting, it is in a relaxed state. In that condition, the blood pressure is known as the diastolic blood pressure, and we say that the range of the diastolic blood pressure is between 70 to 90 millimeters of mercury. So these are two important pressures, and how they are exerted we have now seen. Also there is a unit called pulse pressure, which is nothing but the difference between the systolic and the diastolic pressure. Now the second component of the circulatory system is the blood vessel. There are two types of blood vessels which we have already discussed. They are the arteries and the veins. Now arteries are the vessels which carry blood from the heart to different organs of the body. We know, except for one exception, which is the pulmonary artery, which is carrying deoxygenated blood to the lungs. This is the only exception. Otherwise, all the arteries are offshoots of a bigger artery or the aorta, wherein oxygenated blood flows. That is the reason why the walls of the arteries are little thick, because why? They have to withstand the pressure which is coming from the heart. The blood which is coming with a lot of pressure, they have to withstand that. So arteries are thicker, the walls of the arteries are thick, and they have to receive blood from the heart. Now, arteries further divide into smaller and smaller arterioles, which again divide, and they are then almost microscopic in nature and are known as capillaries. And these capillaries are so thin that they can reach each and every cell in the body. Once the arteries have reached capillary stage, then again the capillaries again join together, they fuse, they coalesce together to form venules. Why? Because now the oxygenated blood has been supplied to each and every cell and the tissue in the body, but the deoxygenated blood has been taken up. That means carbon dioxide rich blood has to again be removed from the tissues and the body cells. So, where will it go? It will again reach back to the capillaries and it will flow back to the venules, and which will again form veins and reach to the heart in the form of superior and inferior vena cavas. So, you can see in this diagram I have explained this is a bigger artery which is dividing into smaller arterioles, and this is a jumble of the capillaries. Now, capillaries on one hand they give oxygenated blood and they again merge back to form venules, veins, and then they give deoxygenated blood back to the heart so that it can get it oxygenated from the lungs. In this diagram, you can see the cross section of the artery and the veins. The only difference is that arteries have little thicker walls and the veins have thinner walls. And now you know that arteries have oxygenated blood and veins have deoxygenated blood. Now the wall of any artery, it consists of three layers: tunica intima, media and tunica adventitia. And veins are also having these layers, but they are thinner in nature. So when you are asked about the differences between the arteries and the veins, you can say the cross sectionally also they are different, and what they carry, that is also very different. This was about the structure and function of the circulatory system and its components, that is the heart and the blood vessels, arteries and veins. Now I will just briefly touch upon what are the various disorders of the cardiovascular system. First and foremost, the most common disorder which we all have heard is of hypertension. Hypertension or the high blood pressure. This is a chronic condition which is characterized by an increase in the systolic and diastolic blood pressure. Systolic blood pressure, we know the range is from 110 to 140 and diastolic is from 70 to 90. But when the blood pressure goes beyond 140, that is the systolic pressure, and the diastolic pressure goes beyond 90 millimeters of mercury, then we say that the person is having high blood pressure, or he is or she is suffering from hypertension. And it can be classified into two main categories, that is primary or secondary hypertension. In primary hypertension, which is most common, that is mostly 90 to 95% of the cases are of primary hypertension. They are because of the persistently elevated blood pressure. Like you have to have a medicine, you have to take your medicines regularly in order to maintain the blood pressure. While in secondary hypertension, it is not a chronic, it is not a persistent condition. It can arise and it can then be removed. It can be due to various reasons like after effect of diabetes or some renal diseases or some cancers. All these can lead to hypertension that is of secondary nature. Next is the hypotension or the low blood pressure, which is again you can understand when the pressure of the blood, systolic and diastolic, falls below 160 millimeters of mercury respectively, and it is generally seen in weak anemic patients or when there has been excessive blood loss. Now the third condition of disorder of cardiovascular is myocardial infarction, wherein there is premature death of the living cells and the tissues of the heart. Now in this condition, the middle layer of the heart, which is the myocardium, here the cells might die, and this can generally result from an abrupt reduction in the blood flow to certain region of the heart. Next disorder is angina pectoris. We have heard about myocardial ischemia, that is pain. It is characterized by a pain syndrome which is associated with partial obstruction in the blood flow. Here the coronary arteries which are present in the heart, they may have some blockage or they may get some obstruction because of certain exertion, maybe exercise, emotion, or some unexplained reasons may be there which can lead to angina pectoris. Another disorder is arteriosclerosis, which is a disorder which is associated with the loss of elasticity when the lumen of the arteries becomes narrow because of various depositions of plaques or thickening of the walls of the arteries. Then we have another disorder, congestive heart failure, and another one which is arrhythmia. Congestive heart failure, we all know that is characterized by decreased blood flow to the various organs of the body due to failure of the pumping action of the heart. And arrhythmias or dysarrhythmias, as we say, is due to the irregular heart rhythm or irregular heart rate, which can be again because of some defect in the electrical conduction system. So that was about the disorders of the heart. We have now today studied about the circulatory system. So we can sum up that we have studied about circulatory system, components of the circulatory system, heart, about the structure of the heart and blood vessels, about various kinds of circulatory circuits that are present in the body, what is a cardiac cycle, and what are the different types of blood vessels and how we can explain the blood pressure and certain disorders of the heart. Now, I would also request all my learners of PGDPSM program to go through this unit wherein you can get in depth more knowledge about this particular topic. And thank you very much.